Second type of graph is VT graph, velocity time graph. Case number 1, VT graph for a body moving with constant velocity. ऑब्जेक्ट जो है कांस्टेंट वेलोसिटी से मूव कर रहा है. V along the y axis and x along the t along the x axis. Let us assume that this is the origin and having the initial velocity something, and that velocity, say for example 5 meter per second or 10 meter per, whatever is there from the origin, we can mark it. But time increases, the speed does not, velocity does not. So velocity remains constant, so we can draw the graph like that. That should be the nature of the graph, parallel to the x axis, time axis के parallel बन जाएगा. In this case, so this is a VT graph for the object is moving with constant velocity. Now suppose if it is given here 1, 2, 3 second, 4 second, 5, 6 like that, and your question is that you have to find out the distance traveled, or if the speed is there, distance traveled from 3 to 6, 3 second to 6 second. So you have to join this one and this one like that. So here it is A, B, C, D. So what we are getting? We are getting this particular one rectangle and A, B, C, D rectangle. In this particular rectangle, if you are going to find out the area, this particular area under the graph, what will happen? If you are going to find the area of rectangle A, B, C, D, then side into length into breadth, say AB into BC. AB is how much? This much. AB, say 6 minus 3, that should be the your this much. AB 6 minus 3, 6 minus 3 second, into BC. BC is how much? Just say for example here the 10 meter per second is there, constant. So 10 minus 0, that is 10. So here it is 3 into 10, that is 30 meter per second. That will be the 30 meter only, because here meter per second, here second cancel, 30 meter. That will be the distance traveled here. It is velocity. I have taken here the velocity, so it is displacement. Had it been speed, then we can write the distance. If the velocity is there, then this is your displacement. If the speed time graph is there, then it is distance. That should be clear. So this is the way how to find the distance travel or displacement travel. So we can write it displacement or distance traveled by the object is equal to area under the graph. right? Important conclusion: distance or displacement. As I told you, why I have written distance and displacement. If the velocity time graph is there, displacement. If the speed time graph is there, distance. So area under the graph. यहाँ पर हम लोग निकालें एरिया अंडर द ग्राफ. ये क्या हुआ? अगर ये वेलोसिटी है तो डिस्टेंस निकल गया, डिस्प्लेसमेंट निकल गया. अगर ये स्पीड है तो क्या निकल गया? डिस्टेंस. एरिया अंडर द ग्राफ, यहाँ से यहाँ हमको निकालना था, इसका एरिया निकाल दिया. व्हाट इज द लॉजिक बिहाइंड इट? Speed logic is that distance is equal to speed into time, or displacement is equal to velocity into time. That's the logic. That's why velocity into time, speed into time, like that. That's the logic, basic. Second case of the VT graph, velocity time graph for an object moving with uniform acceleration, and it is given initially body is at rest. Again, y-axis, x-axis, always time is, as it is independent, we are taking it along the x-axis, and here the velocity along the y-axis. Object is initially at rest. Yeah, now uniform acceleration, definitely equal change in velocity in equal interval of time. So the graph goes like that. That should be the graph. Now in this particular graph, that's the curve, a straight line, not the curve, straight line passing to the origin. Now the point is, how will you find out the acceleration? Object is moving with the acceleration, uniform acceleration. How will you find the acceleration is equal to how much? So only thing is that find out the slope of the graph, or you can mark it O, A, B. Logic: velocity, change in velocity by time taken to change. So acceleration is equal to slope of the graph, that is your AB by OA, right? The value of OA and AB you have to find out. So acceleration will be the slope, and that will be here the time में जो चेंज हुआ, यहाँ से यहाँ कितना वैल्यू है वो लिख दिए, यहाँ से यहाँ कितना वैल्यू है वो लिख दिए. We can choose any point also. Another way, choose any point and like that. We can choose any small triangle, right angle triangle also. Here also, whatever the value will be there, the value del V and here del T. यहाँ पर मान लेते हैं A, B, C, ये पॉइंट है D, ये पॉइंट है E. तो यहाँ पर इस राइट एंगल ट्रायंगल में निकालेंगे तो भी मेरा यही एक्सेलरेशन आएगा. Acceleration here for this right angle triangle, A is equal to CD by EC, and we can easily find out. Same value you will get. Same value. You can take the longer or the bigger right angle triangle or smaller right angle triangle anywhere. But you have to see what is this particular value and this value just to divide. So these are the slope. So here the slope or the gradient are very similar. यहाँ पर निकालेंगे, यहाँ निकालेंगे, यहाँ निकालेंगे. Slope is similar. So acceleration you will get it by finding the slope. Slope means P, you can write the P by B also. Another way to find out P by B. ऐसे करके निकालेंगे. Slope निकालेंगे. Object is moving with a uniform acceleration. This is a VT graph. From the VT graph, you remember, from the VT graph, the slope is equal to the acceleration. That uniform acceleration you can easily find out. if another point of this, if the object has initial velocity and moving with the uniform acceleration, यूनिफॉर्म एक्सेलरेशन से मूव कर रहा है ऑब्जेक्ट और अभी इनिशियल वेलोसिटी ज़ीरो नहीं है, देन अगेन हाउ वी आर गोइंग टू ड्रॉ इट दिस वे. दिस इज योर y axis, this is the x axis. Here we have taken the v, here the t, vt graph. Object is having some initial velocity and then say initial velocity u, then the graph is like that for the uniform accelerated motion. Graph is like that. Say here it is the final velocity v. So from this also, how will you find out the acceleration? Choose any 2 points. I have chosen this point and this point. Say this point is A, this is B, this is C. This is right hand triangle, and find out the value of BC and AB. So acceleration will be BC by AB. That is slope. Slope of the graph will be the acceleration, or P by B, perpendicular by base. This value you have to find out from this graph, whatever the marking is there, यहाँ से यहाँ, and this value from here, vertical axis. This is same as this particular distance. This is same as this particular distance. So logic is acceleration is equal to change in velocity by logic. What should be the logic behind it? Change in velocity by net time to change from initial to final. That is the logic. So del v is a vertical axis and this is a horizontal axis. So this is way how we are going to draw it. Another important point from this graph only, say for example you have to find out the displacement undergoes this velocity time graph. Displacement, magnitude of displacement को निकालना है. तो that should be equal to area under the graph. इसका एरिया निकाल लेंगे फ्रॉम VT ग्राफ. यू रिमेंबर VT ग्राफ अगर है तो उसका एरिया अंडर द ग्राफ, दैट यू हैव टू फाइंड आउट. दैट एरिया विल बी, यहाँ से मान लेते हैं ये ग्राफ था, यहाँ इसका टोटल एरिया OPQ and this is your S. So area of this is what should be the, इसका एरिया क्या बोलेंगे, ये जो है the shape is of this is your trapezium, area of trapezium. You can easily find out area of trapezium and that will be the magnitude of the displacement. You remember magnitude of the displacement. So if VT ग्राफ से डिस्प्लेसमेंट निकालना होगा तो क्या करेंगे, अंडर द ग्राफ एरिया यू हैव टू फाइंड आउट. ठीक, मैग्नीट्यूड ऑफ द डिस्प्लेसमेंट. ये एरिया ऑफ ट्रेपेजियम, इसका एट क्या है, ट्रेपेजियम का एरिया क्या होता है, हाफ सम ऑफ द पैरेलल साइड्स इनटू सेपरेशन. ये तो पढ़े हो तुम लोग. So area of trapezium, or you can another way is that if you are going to make this particular area into two parts, this will be the right angle triangle and this will be the triangle. इसका एरिया निकाल लिया, इसका एरिया निकाल लिया, दोनों को जोड़ दिए, दोनों को ऐड कर दिए. लेकिन हम लोग दो पार्ट में क्यों करेंगे? वी नो द एरिया ऑफ द ट्रेपेजियम हाफ इंटू सम ऑफ द पैरेलल साइड इंटू द सेपरेशन और इंटू द हाइट. That is your area of the trapezium, and that will give you the displacement. What is the logic behind it? Displacement is equal to velocity into time. That's the logic, right? So पहले ये निकाले magnitude of displacement VT ग्राफ से, पहले वाले केस में भी इनिशियली बॉडी जब रेस्ट में था, इनिशियली यहाँ पर ज़ीरो वाला, तो इसका हमको एरिया निकालेंगे। अगर ये वाला पार्ट का हम लोग एरिया निकाल लेंगे तो क्या मिलेगा, मैग्नीट्यूड ऑफ द डिस्प्लेसमेंट, मैग्नीट्यूड ऑफ डिस्प्लेसमेंट फ्रॉम द वीटी ग्राफ, रिमेंबर मैग्नीट्यूड ऑफ डिस्प्लेसमेंट हम यहाँ पर भी निकाल सकते हैं। तो एरिया ऑफ, ये कौन सा एरिया है, राइट एंगल ट्रायंगल, एरिया ऑफ ओ ए बी इज इक्वल टू हाफ बी इंटू एच कर देंगे, बी इंटू एच, यू विल गेट द एरिया ऑफ द राइट एंगल ट्रायंगल, दैट विल बी इक्वल टू मैग्नीट्यूड ऑफ डिस्प्लेसमेंट, मैग्नीट्यूड ऑफ डिस्प्लेसमेंट निकालें, क्योंकि वेलोसिटी है इसलिए डिस्प्लेसमेंट। अगर ये स्पीड होता तो हम क्या लिखते हैं, डिस्टेंस। Another very important, the VT graph when the object or when the velocity of the object decreases uniformly, अभी तक तो increase हो रहा था, decreases uniformly means retardation. This is a case of retardation, means negative acceleration. Then this is a x-axis time and this is your y-axis velocity, means here origin, body decreases, the velocity of the body decreases uniformly, means having the initial velocity, जैसे एक बस जा रही है कुछ वेलोसिटी से, मान लेते हैं 10 मीटर पर सेकंड से ट्रैवल कर रही है, एंड द ड्राइवर ऑफ द कार अप्लाइज द ब्रेक्स एंड आफ्टर ट्रैवलिंग टू सर्टेन डिस्टेंस इट कम्स टू रेस्ट। तो इनिशियली उसमें वेलोसिटी है यहाँ पर, इनिशियल वेलोसिटी, देन रिटार्डेड यूनिफॉर्मली, देन दिस ग्राफ यू विल फाइंड, द ग्राफ लुक्स लाइक वेलोसिटी धीरे 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 डिक्रीज हो रहा है, it decreases and it becomes 0. That should be the case of when the VT graph, when the velocity of the body decreases uniformly to 0. Velocity देखो 0 हो गया कुछ टाइम के बाद. Now in this particular case, if anyone is going to find what is the value of retardation निकालना means negative acceleration, then again you have to find out the slope. Either you have to choose any 2 point and drop the perpendicular like that. So you have chosen this particular right angle triangle. You can use the whole bigger triangle also. I have chosen this small right angle triangle A, B, C. So that should be the your this particular slope. We are going to find out the slope निकालना होगा. अब यहाँ पर ये जो डिस्टेंस है दैट इज द स्लोप इज इक्वल, कैसे क्या डिस्टेंस लेंगे, अगेन हियर द P एंड दिस द B, परपेंडिकुलर एंड द बेस. स्लोप निकाल रहे हैं P by B मीन्स AB by BC. AB कितना आएगा, जो भी आएगा दिस माइनस दिस, जो भी इसका वैल्यू आ रहा है यहाँ पर रिटार्डेशन हम लोग निकाल सकते हैं, दिस बाई दिस. तो यहाँ पर हम लोग वेलोसिटी क्या निकाल रहे हैं, यहाँ पर हो जाएगा ये डिस्टेंस, यहाँ पर हो जाएगा ये डिस्टेंस. ये डिस्टेंस कहाँ से निकालेंगे, यहाँ से निकालेंगे. ये डिस्टेंस कहाँ से निकालेंगे, यहाँ से निकालेंगे. और ये रिटार्डेशन हमेशा निगेटिव में आएगा, निगेटिव वैल्यू आएगा, ज़्यादा वेलोसिटी से कम में आ रहा है. सो यहाँ पर एग्ज़ाम में यहाँ पर ये वैल्यू दिया रहेगा, वॉट एवर द वैल्यू विल बी देयर एंड यू कैन इजीली फाइंड आउट रिटार्डेशन. नाउ इन दिस वे if the question is that you have to find out the magnitude of displacement, velocity time graph is there. Again same method, we have to find this particular graph total and you have to find the area under this graph. इसके ये ग्राफ का के अंदर का एरिया निकाल लेंगे, इज इक्वल टू एरिया अंडर वी टी ग्राफ। यहाँ पर हाफ बेस इंटू हाइट, हाइट हो जाएगा, राइट एंगल ट्राइंगल है, बेस O to this particular point is a base and height is this is your H. So area, if you are going to find out, you will get the magnitude of displacement. This is the way how we are going to draw it. Okay, thank you.